There's a telescope in Chile that never sleeps. Every night, high in the Atacama Desert, it opens the largest digital camera ever built and stares into the darkness. But it does not observe the universe the way other telescopes do. It does not focus on a single galaxy for weeks, waiting for the perfect image. It does not capture space as a frozen moment in time. Instead, it watches everything over and over again. Every 3 nights, the Vera Rubin Observatory scans the entire visible southern sky, searching for anything that has moved, brightened, vanished, exploded, or appeared where nothing was supposed to exist. And in its very first months, before its full mission had truly begun, it started finding things that seemed almost impossible. A single image containing 10 million galaxies, a river of stars stretching 163,000 light-years from a spiral galaxy, more than 11,000 newly discovered asteroids, a rapidly spinning object so massive that physics suggests it should have torn itself apart, a star in the Andromeda Galaxy that may have collapsed directly into darkness, and mysterious objects from other star systems silently passing through our own like visitors from places humanity may never reach. The Vera Rubin Observatory was built to map the universe, but what it captured first seemed far more unsettling. It offered evidence that the sky is changing faster than we ever imagined. Perched atop a mountain in Chile beneath some of the driest and darkest skies on Earth, the observatory is carrying out the legacy survey of space and time. The name sounds calm and scientific, but its mission is extraordinary. Rubin is creating a 10-year movie of the universe, not a single photograph, but a continuous record of change. Every few nights, it scans the entire visible sky from the southern hemisphere and compares each new image with the last. If even the smallest detail has changed, a moving asteroid, a dimming star, a flaring galaxy, or an object that has suddenly vanished, the observatory immediately notices. Every change generates an alert. During early testing, Rubin's alert system produced hundreds of thousands of alerts in a single night, and once fully operational, it is expected to generate millions every night. Each alert points to something in the universe that is different from before. This is what makes the Vera Rubin Observatory unlike almost every telescope that has come before it. The Hubble Space Telescope transformed astronomy by revealing extraordinary detail. The James Webb Space Telescope revolutionized our understanding by observing the universe in infrared light and peering deep into cosmic history. Rubin, however, changes astronomy in an entirely different way. It gives the sky a memory. For thousands of years, humanity looked upward and believed the heavens were mostly unchanging. Stars appeared fixed in place, constellations seemed eternal, and galaxies looked distant, silent, and frozen in time. But Rubin is revealing that this picture was only an illusion. The sky is constantly alive with motion. Asteroids race through the solar system. Stars explode without warning. Black holes may form in unexpected ways. Interstellar objects pass through our cosmic neighborhood, and galaxies stretch, collide, merge, and expose faint structures that older surveys could never detect. Because Rubin repeatedly returns to the same regions of the sky, it can identify changes that no single observation could ever reveal. This is a new frontier in astronomy, not simply exploring deep space, but watching space itself evolve. The observatory's first results demonstrated just how much had been hidden from us. On June 23, 2025, the world saw Rubin's first public images, and one of them was almost impossible to comprehend. A single composite image of the Virgo cluster contained approximately 10 million galaxies, not stars, but entire galaxies. Each one may contain billions of stars, countless planets, black holes, glowing nebulae, and worlds that remain completely unknown. And this astonishing image represented only a tiny fraction of what Rubin will eventually observe. If someone attempted to examine every galaxy in that image for just 1 second each, without ever stopping to eat, sleep, or rest, the task would take months. For Rubin, however, this was only the beginning. Over its decade-long survey, the observatory is expected to record billions of galaxies, creating one of the most comprehensive maps of the universe ever assembled. Hidden within those first remarkable images was another unexpected discovery, a stellar stream flowing away from the spiral galaxy Messier 61. This immense river of stars stretched an incredible 163,000 light-years, making it even larger than the diameter of our own Milky Way galaxy. Until Rubin observed it, no one knew it existed. This discovery perfectly demonstrates the observatory's extraordinary capabilities. It is designed not only to detect bright, obvious objects, but also to uncover faint structures spread across enormous regions of the sky. Features too dim, too wide, or too subtle for many previous telescopes to detect. A stellar stream is far more than a beautiful cosmic structure. It is evidence of immense gravitational violence. Such streams form when a smaller galaxy or star cluster passes too close to a much larger galaxy, allowing gravity to tear it apart and stretch its stars into an enormous river flowing across space. These stellar streams are the fossil records of galactic destruction. They reveal how galaxies grow by consuming smaller systems, how invisible dark matter shapes the movement of stars, and how the universe builds its largest structures through billions of years of gravity, collisions, and cosmic evolution. The Vera Rubin Observatory captured one of these ancient relics that had been hiding in plain sight, demonstrating that even familiar regions of the sky still hold extraordinary secrets waiting to be discovered.